When dealing with mismatched conduit levels in an outdoor electrical installation, a splice box rated for outdoor use can provide a viable solution. This involves several key considerations to ensure a safe and code-compliant installation. Firstly, the splice box must be appropriately sized for the number and size of the conductors that will be spliced within it. Calculating the required box fill involves considering several factors. One must account for the number of conductors, the size of the conductors, any devices such as splices or terminals present in the box, and the number of conduit entries. According to the National Electrical Code, or NEC, Section 314.16, each conductor that originates outside the box and terminates or is spliced inside the box is counted as one conductor. Conductors that run through the box without a splice or termination are generally counted as one conductor as well. Each conductor must be counted individually based on its American wire gauge, or AUG, size. The volume occupied by each conductor is determined by NEC Table 314.16a. For example, a number 14 AWG conductor requires 2 cubic inches, a number 12 AWG conductor requires 2.25 cubic inches, a number 10 AWG conductor requires 2.5 cubic inches, a number 8 AWG conductor requires 3 cubic inches, and a number 6 AWG conductor requires 5 cubic inches. Any devices, such as splices or cable clamps located inside the box, also contribute to the box fill calculation. NEC Section 314.16b specifies that one or more internal cable clamps count as a single conductor based on the largest conductor entering the box. Similarly, each device, such as a switch or a receptacle, counts as 2 conductors based on the size of the conductors connected to it. If the box contains equipment grounding conductors, a specific allowance must be made. NEC Section 314.16b5 requires that all equipment grounding conductors entering the box be counted as a single conductor based on the largest equipment grounding conductor present. Once all the individual volumes have been determined, they are summed together to calculate the total required box volume. The splice box must have an internal volume equal to or greater than this calculated value. The volume of the box is typically marked on the inside of the box itself. Secondly, the connections inside the splice box must be made securely using approved methods. Common methods include wire nuts and crimp connectors. Wire nuts are color-coded, and each color is designed for a specific range of wire sizes. To properly use wire nuts, the conductors must be stripped to the appropriate length, twisted together tightly, and then the wire nut is screwed onto the twisted conductors until it is securely in place. Crimp connectors, on the other hand, require a crimping tool to create a secure mechanical and electrical connection. The correct size of crimp connector must be selected for the wire size, and the crimping tool must be compatible with the connector type. The conductors are inserted into the connector, and then the crimping tool is used to compress the connector tightly around the conductors, creating a permanent bond. Regardless of the connection method used, it is crucial to ensure that the connections are mechanically sound and provide good electrical conductivity. A loose or poorly made connection can lead to overheating, voltage drop, or even electrical fires. Thirdly, the splice box must be properly sealed to protect the connections from moisture and weather conditions. Since the installation is outdoors, the splice box must be rated for wet locations. These boxes are designed with features such as gaskets and watertight hubs to prevent water from entering the enclosure. When installing the splice box, ensure that all conduit entries are properly sealed using appropriate fittings and sealant. Any unused openings in the box must be closed off with watertight plugs. Inspect the box regularly for any signs of damage or deterioration and replace it if necessary. Fourthly, the splice box must be securely mounted in a location that is accessible for future maintenance if necessary. The mounting location should be chosen to minimize the risk of physical damage to the box and its contents. The box should be mounted on a stable surface using appropriate hardware such as screws or bolts. The location should also allow for easy access to the box for inspection, testing, and repairs. Avoid mounting the box in areas where it may be subject to standing water, heavy traffic, or other hazards. Fifthly, the conductors in the splice box must be spliced together in such a way as to maintain the integrity of the circuit, including proper insulation and protection against physical damage. When splicing conductors, it is important to use the correct size and type of wire for the application. The insulation on the conductors must be in good condition and free from damage. If the insulation is damaged, it must be repaired using electrical tape or heat shrink tubing. The conductors should be spliced together using a method that provides a secure mechanical and electrical connection, such as wire nuts or crimp connectors. The splices should be staggered to minimize the overall size of the splice bundle. Once the splices are complete, they should be carefully wrapped with electrical tape to provide additional insulation and protection. The tape should be applied in overlapping layers, starting from one end of the splice and working towards the other. It is also important to ensure that the splice box is properly grounded. The equipment grounding conductor should be connected to the metal enclosure of the splice box using a grounding screw or other approved method. This will help to protect against electrical shock in the event of a fault. In summary, using an outdoor rated splice box to address mismatched conduit levels requires careful attention to detail. Following these guidelines will help to ensure a safe, reliable, and code-compliant electrical installation. It's always best to follow the manufacturer's instructions for the specific splice box being used. Always de-energize the circuit before working on any electrical equipment, and if unsure, consult a qualified electrician.